Okay. All right. So let me take a roll real quick. I think everyone's here. Okay. Oops, wrong class. Okay. So from yesterday, what we're doing this whole lesson is essentially answering the same questions you answered on the test, the group test, and the individual test. Where is it increasing, decreasing? Where are the maximum minimums? Where is it concave up, concave down? Where are the points of inflection? If you look at the group test, you did that on your group test. You did that on your individual test, okay? The difference today is I don't give you an equation. I give you a graph. And not only do I give you a graph, but I give you a graph of its derivative, of the function's derivative, okay? So remember, first thing, they won't always give you the graph of the derivative, but first thing you do is they'll always tell you what graph it is. So the first thing we did was state that, okay, this guy right here is the graph of f prime, right? We said that yesterday. Okay, so if it's the graph of f prime, what are the y values going to represent? What is this graph going to represent, I should say? We know what the x values are. X values are always the same. What are the y values going to represent? Slopes, yeah. Right, slopes. Right, slope values. Okay. And then the derivative of this, so f double prime, right? That's where we represent the derivative of the graph is the second derivative, right? So that's what we've been doing. We did it for letter D. Now we got to do it for letter E. Concave up and concave down. So we got to find where is it concave up, where is it concave down, and we have to justify your answer. Okay. So we know where points of inflection are. We did that yesterday. We said -2 and 4 are points of inflection. So let me mark those on here. So -2 and 4, right? Those are points of inflection. We said that yesterday. Remind me, why are they points of inflection? Why are they points of inflection? There you go. The slope is 0 at those points, right? At this one right here, the slope is 0. The slope of the tangent line is 0. It's horizontal, right? This guy, not necessarily, but it's got a corner, right? So a corner means the derivative is going to be undefined. Okay, so we said that. We said that in our explanation. Again, like I said yesterday, when I was finishing grading your test, a lot of you wrote like some paragraphs, right? And I crossed it all out and put something like that, because that's essentially what you're saying. Because you guys, I knew, see, that's the thing. You guys up here, it makes sense to you guys. And I get that. I 100% get that. It makes sense to what you wrote. But when someone else has to read it, it's kind of hard to make sense of it. And so a lot of times I get students who are like, Mr. Flores, I put my answer here. That's what I put. And I'm like, yeah, that doesn't say that, right? It says it in your head, but it doesn't say it to a third party, right? Anyone. This clear sense, because the second derivative changes signs, right? The second derivative changes signs. That's the reason why it is it is a point of inflection. Okay. How do I know that though? How do I know that this graph at this point here and this point here is where the second derivative changes signs? How do I know that? In other words, what do I mean by that? What do I mean by that when I say that? When I say the second derivative changes sign. That's right. That's right. That's justification. This is not a wrong answer. It's a correct answer. But what does that mean in terms of the graph? What's changing signs? I know the second derivative is, but where is that? What can I locate that on the graph? What does that mean? Yeah, you're right. Okay, the slope of f prime. So let's start here. So as I go, is it positive or negative? F prime is, but the slope of f prime, yeah, you, Raj, are saying the slope of f prime, which is f double prime, right? So slope of f prime, right? Okay, so slope of f prime, positive or negative? One more time. Slope of f prime, positive or negative? Negative, good. Tell me when it changes. Right there, at that dot, right? At that dot, it does something, right? It's decreasing, 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 decreasing. At that dot, it changes direction. It's not decreasing anymore. Now it's increasing. Now it's increasing, now it's increasing, now it's increasing. Oh, it changes direction again, right? It changes direction again for the last time. That's why this dot and this dot are points of inflection, okay? So beforehand, it's doing one thing. In the middle, it's doing another thing. And at the end, it's doing a third thing. Okay, 3 parts to it. Okay, so we have to write those 3 parts. Is it concave up, concave down? What is it doing? At those dots, it's not do it's neither. It's neither concave up nor concave down. Before those, in the middle, and after, what is it doing? Which one of those is it doing? Okay. So remind me, how do I know if it's concave up? How do I know if it's concave up? Yes. No, you can't. No, you're right. You're absolutely right. But here's the thing. If you use that justification, it's going to get you the wrong answer because that's not what we're looking for, right? How do I know if it's concave up and concave down? Okay, so that you're almost there. And again, justification is important because I have a lot of people saying stuff like that. And I have lots of slopes here. I have the y values are slopes. I have slopes of this, right? I have lots of slopes. So you got to be more specific than that. How do I know if something is concave up or concave down? You can look on your paper because I guarantee you did it on your paper, on your group test. How did you know that things were concave up or concave down? There you go. That's specific right there. The second derivative, the second slope, right, is positive. It's concave up. If the second derivative is 0, that's going to be my justification right there. Right there. Because this. That's my justification. The reason I write it down is because it helps me. Because now I know what I'm looking for. Is the second derivative positive or negative? Well, we just said that. When I followed my pen here, right? My pen following, you guys were telling me, oh, it's positive, it's negative, it's positive, it's negative, it's increasing, it's decreasing. That's all we got to do. So from here to here, that's one, that's another, and that's another. 3 parts to it. So is the yellow concave up or concave down? So if I'm looking at the original, because what Roman said was correct, it was absolutely holds water, right? Holds water. That's only true if you're looking at the original graph, right? If you were looking at the original graph, then you would look for where does it hold water, where does it spill water. That works. But the reason it doesn't work for this guy is because this is not the original graph. This is the derivative graph. Okay? So the yellow part, is it going to be concave up or concave down? Why concave down? There you go, right here. Because this is true here. The slope of this yellow guy here is negative. It's going downhill, right? It's going downhill. It's decreasing, right? So I know that that's going to be where it's concave down. So let me write that down. Okay, so it's going to be concave down from -6 to -2. Okay. Now the pink part, is that concave up or concave down? Is it doing the same thing as the yellow, or is it doing something completely different? It's doing this, it's doing completely different. It's going back uphill. It's increasing. So that means it's concave up. So -2 to 4. And then the last part, that blue aqua color at the end, is it doing what the yellow was doing, or is it doing what the pink is doing? It's doing what the yellow. Yeah, it's following the yellow's pattern, right? It's going downhill. So that one is concave down. Okay. Or 4 to 6. Okay, there's my answer. Let me include my justification here. Because f prime is positive, because f double prime is negative. Okay, so there are levels, right? The original is at the top. Then you have the first derivative. Then you have the second derivative. So sometimes they'll start you, most of the time they'll start you in the middle. They'll start you in the derivative, and they'll ask you questions about the original and about the second derivative. So you got to go up, you got to go down. Once in a blue moon, they'll give you the original and ask you questions about the derivative and the second derivative. I don't think I've ever seen one where they start you with the second derivative. I don't think I've ever seen one like that. Most of the time, 90% of the time, they will start you with the first derivative and want you to go up. Tell me about the original. And go down. Tell me about the second derivative. Okay. So that's why I put one on here that was the first derivative on there, because that's the most one you're more likely to see. The one you'll see on the test, I should say. Okay. All right, last part. Last part. Find the equation of the tangent line. Find the equation of the tangent line. So they give us a little bit of information. They say f of -2 equals 4. What does that mean? What does f of -2 equals 4? What does that mean here? We've seen that before many, many times. What does that mean? F of -2 equals 4. What is the -2? What is the 4? Yep. So which one's x and which one's y? Which one's x and which one's y? Is 4x, 4y? Perfect. That's a point. Got a point. That's a point. Okay. Find the equation of the tangent line. So we're finding the equation of a line, right? So that means y minus y1 equals slope x minus x1. Point slope, right? Find the equation of the tangent line for the original at x equals 2, -2. Which parts of this can we fill in already? Do we know? The x and y, right? The x and y. So the x goes by x, so -2 goes by -2. The y goes with the y over here. I just have to find slope. How do I find slope at -2? Because that's what I got to do, right? I got to find slope at the x value, -2. How do I find slope at -2? Give you a hint. It's not really a hint. The only thing we have to refer to, because we have these things to refer to, right? F of -2 equals 4 and x equals -2, but we've already used those. The only other thing that we have to refer to is what? What's the only other thing we have to refer to in this problem? The graph. Yeah, that's the only thing we have, the graph. So I'll give you a hint. The answer's on the graph. How do I find the slope at -2 using the graph? If I had the equation, I'd just plug in -2, right, to the derivative, right? Just plug in -2 to the first derivative, and boom, there's your slope. I don't have that though, but I can use the graph. So how do I use the graph to find the slope at -2? Hmm? That will get slope. That will give me slope, but even easier than that. Even easier than that. Write your notes. Yeah, Ella? That's kind of like what Roman said. That would work, but even easier than that. It's even easier than that. Yeah. Exactly. Didn't we say the y values were the slopes, right? We said that. That's why we wrote that earlier, right? The y values are the slopes. So what is the y value at -2? What is the y value at -2? -2, right? So that means at this point here, which also happens to be a point of inflection, but at -2, the slope was -2. Okay. So y minus 4 equals -2, x plus 2. Okay, done. Okay, so what we're going to do next is sum this all up in language you can understand. So when I ask you these questions on assignments, tests, group tests, all that stuff, you have some notes, further notes that make sense to you. Okay. So before we do that though, look at what we've done so far. Look at the examples we've done so far. Look at all the examples. More importantly, what you wrote down. What you wrote down. Is there a lot of calculations there? None. We didn't do any calculations, right? But this is definitely one of the harder things to do in all of calculus. This lesson we just did today. Another thing, right? Students think, oh, calculations are hard. No. You guys are really good at calculations. Calculations are really good. The last test you guys did had quite a few calculations, and you guys did well on that. Okay? This is the hard stuff here. This is the hard stuff, right? This is the hard stuff because you have no calculations to fall back on. All you want to do is plug in numbers. I want to plug in numbers, plug in numbers. Well, there are no numbers to plug in, right? It's stuff you have to know. You have to have background knowledge going into it. That's the hardest stuff. That is the hardest thing. Okay? That's the hardest thing to do because, like I said, you just have to visualize it and be able to know. You have to have background knowledge of what you're looking for, what you're looking at, what you're looking for, and how to find it. You have that background knowledge, but again, you're looking at it from a different perspective, right? You're looking at the same question. Those questions you had on your group test, same questions I'm asking you on this, but now you're looking at it from another angle, and it could be difficult. It could be difficult. Okay, so when we had lessons like this, all of these calculations here, you guys do that, right? You guys could do all of those steps. Those are just steps, right? Not a lot of critical thinking here. Oh, you do this step, you do this step, you do this step, you do this step, right? That's not critical thinking. This one, there's a lot of critical thinking, right? Because I'm going to give you another one in a second here, and that's going to look different than this. And I'm going to ask you the same exact questions. Okay? So this is where you really earn your money here, because some students can do this, some students struggle with this. So this will kind of separate who can do it versus who can't. Okay? So here we go. Now we're going to write notes to ourselves. on how to do these things, because we just did all of these things, right? We did all of these things with an example. So we're going to write notes to ourselves, okay? So how do I know where the critical points are? How do I know where the critical points are for the original when I'm looking at a derivative graph? It was the very first question I asked you on this paper, okay? Yep. We look at the zeros, right? So write that down on yours. So I'm going to write it down. Don't necessarily stay faithful to what I do because it makes sense to me, but I'm not the one who has to look at this later, right? So write something that'll make sense to you, okay? So look for the zeros. Look for the zeros on the graph. That's one way to say it. Another way to say it, where it touches the x-axis or has a point where it's undefined, right? That's another way to say it. All saying the same thing, but what makes sense to you versus what makes sense to me. Don't put what makes sense to me because I'm not the one who has to do the assignments and take the test. I already did that, okay? Put what makes sense to you, okay? So look for zeros, any zeros or undefined. We didn't have any undefined, but if there are undefined, that's also going to be a critical point, okay? Touches the x-axis, crosses the x-axis, anything like that, okay? Anything like that. I'll just put what I put. Touches the x-axis or has an undefined point. Those are the two things I'm looking for. Okay. Relative maxima. So the next question was part B said maximum, minimum, maximum and minimum. How did I know that I had a max? I didn't have a min on this question. Yes, I did. I had a minimum on this question. How did I know that I had a max or a min? What was the graph doing? What was the graph doing? When the graph did what? Not a slope of zero. That's going to be point of inflection. Point of inflection. It's definitely going to go on here, but it's not for that one. There you go. When they change from one to the other. Okay. So in this case, relative maxima, when the graph crosses the x-axis from positive y values to negative y values. That's the maximum. When it goes from positive y values, because the y values represent the slopes, right, to negative y values. Okay. And then minima is just going to switch the positive and negative. When the graph crosses the x-axis from negative y values to positive y values. Like I said, if that makes sense to you, write it down. If it doesn't make sense to you, put it in your own kind of shorthand or whatever you do, okay? I'm not, in my other classes, like if I was teaching a Math 1 class, I would make them write it down exactly word for word like I had it because they're not able to do that. You guys are able to do that, okay? You guys are at a point where you guys are able to put it in your own words and make it fit to what you understand. So I don't want to make you do something that you're not going to be comfortable with. Okay, so if you want to put it in your own vernacular, or if you can shorten that to shorthand that you'll remember it later, go for it. Okay, I'm not going to I'm not going to make you do that because I know you guys are a little better than that. Okay, your abilities are a little bit more than others. Okay. All right. So the next question said increasing, decreasing, increasing, decreasing. We said it was increasing from -6 to -4 or 0 to 6. Not 0. Yeah, 0 to 6. And it was decreasing from -4 to 0. How did we know that? What did we look for on the graph? What did we look for on the graph? When the graph, because the better you can do this, the easier these problems will be. These problems have the ability to be very easy if you can do a good job here, because you know exactly what you're looking for. If you know exactly what you're looking for, you can do these problems no problem. It's when you don't know where you're going. That's the issue. Then these problems can be the hardest. Mm-hmm. There you go. So when the graph has positive y values, right? When the graph had positive y values, or another way to say it is when the graph is above the x-axis, right? When the graph is above the x-axis. Anytime the graph is above the x-axis, it's going to be increasing. Anytime the graph is below the x-axis, it was decreasing, right? That means it was negative. It had a negative y value. That's what that means. It has a negative y value. Okay. Okay. Points of inflection. Points of inflection. When did I know that there was a point of inflection? I had a point of inflection. Let's see here. I think I had two of them, right? At -2 and +4. -2 and +4. How did I know those were my points of inflection? How did I know those were my points of inflection? At -2 and +4. Yeah, Phil. There you go. When the slope changed signs from one to the other. When the slope of the graph changed signs, either from positive to negative or vice versa, right? I think I had it. I had 3 sections on mine, right? The last problem we just did, I had 3 sections: yellow, kind of a pink color, and the blue color, right? The yellow represented where the slope was negative. The middle part here, the pink color, represented where the slope was positive, and then the blue at the end represented where the slope was negative, right? And when did I change? At those blue dots, right? At those blue dots, that's when I changed. Those are points of inflection because the slope of this graph changed signs. It went from negative to positive or positive to negative. Okay. All right. Concave up, concave down. We just did this one. This one should be fresh in your mind. We just did it 10 minutes ago. So how did I know concave up, concave down? What told me that this part's going to be concave up and this part of the graph is going to be concave down? It was the slope. It had something to do with the slope, right? When the slope of the graph was what? When the slope of the graph was positive. Increasing, in other words, increasing. When it was increasing, concave up. The opposite was true when it was concave down. Okay? When the slope of the graph was negative, that's where it's concave down. Okay? Very last thing before I let you guys work on the problem, the last problem on your own. How do I know? How do I find slope of the original equation at a specific point? How did I find slope of a specific point at -2? Remember I found slope of -2 was -2. What did I use to do that? The y values, yeah. You look at the y values, exactly. The y value of the graph. Of f prime at the same x value. So the x value was -2. So what was the y value at -2? -2. There's my slope. Okay. Okay, so we got about 20 minutes left. I want you to use that to work on the last question. The last question has the same types of problems, the same questions that I gave you, different graph though. So it gives you a little bit of information at the top, and then they want you to answer the questions there. Okay. So I'll give you about 10 minutes, and then the last 10 minutes we'll go over together. Okay. Remember, include justification as well. Justification as well. Okay. Use these. I'm telling you right now. Use these to help you. That's why they're there. Okay. That's why they're there. Eventually, you'll get to a point where you don't need them. Great. We're not there yet. Okay. We just did this. We just started this yesterday. So don't put too much stress on yourself if you can't do this in your head. Okay. Use those. Stick to the reasons. Are your notes to yourself. Okay. So let's talk about this. Okay. So let's talk about. So it asks you each of the same questions: critical point, increasing, decreasing, maximum, minimum, concave up, concave down, points of inflection. Okay. So the first one is critical point. Well, according to what I wrote down, critical point is where it touches the x-axis or where it's undefined. Okay. So touches the x-axis, 1, 4, 6. 1, 4, 6. Okay. 1, 4, and 6. So x equals 1, x equals 4, x equals 6. What's my justification? I can't write because it touches the x-axis, right? That's your steps. That's not justification. So what was your justification? Perfect. That's what I have. F prime equals 0. F prime of x equals 0. Those are zeros, right? Okay. Letter B. Increasing, decreasing, increasing, decreasing. Okay. Well, I wrote down earlier that increasing, decreasing. Let's see, increasing, decreasing. There it is. I wrote increasing, decreasing. Increasing is when it's above the x-axis. Decreasing is when it's below the x-axis. Well, first thing, pretty important that I skipped was this stuff up here. The stuff at the top, the background info, that's important because a lot of times they'll give you information and you're going to figure out if it's the derivative. So it says the function is defined, means there's no spots where it's undefined, and it's differentiable. Everywhere there's a derivative, from point to point, there's a derivative. There has to be a derivative at every point in between there, okay? It's a closed, so that means it goes from 0 to 8. Dots are included. The graph of f prime, so this is a derivative graph, right? There's horizontal tangents at x equals 2, 4.75, and 6. So they actually tell us where the horizontal tangents are here, okay? Which means slope is 0. That's going to help us in one of the problems. Not yet, but it'll help us. So increasing where it's positive. So from -9 to 1. From 4 to 6. And then from 6 to 8. Okay, so from 0 to 1, 4 to 6, or 6 to 8. Justification, because f prime is positive, or f prime is greater than 0. That's where it's positive, okay? Decreasing, the only place it's decreasing is from 1 to 4. 1 to 4. Decreasing because f double prime is negative, or sorry, f prime is negative, okay? F prime is negative, okay? All right, next one. Let's see, maximum minimums, Well, my maximum minimums, for maximums, it says when the graph crosses the x-axis from a positive y value to a negative y value. And the relative minima is the opposite, when it crosses the x-axis from a negative y value to a positive y value. So for maximum, it's going to cross from positive to negative at 1, right? So 1 is going to be a maximum. And then at 4, it crosses from negative to positive. So at 4, it's going to be a minimum. Justification for maximum, because f prime changes from positive to negative. Justification for minimum, f prime changes from negative to positive. Okay. How about at 6? What's 6 going to be? Maximum or minimum? What's 6 going to be? Yeah, Roman? There you go. It's an either. Exactly, just like Roman said. It's an either because it doesn't change. It stays positive. Okay, so I don't even have to write that one down for this question. Okay. Point of inflection. Okay, points of inflection. I wrote down that points of inflection are when the slope changes from positive to negative or vice versa. When the slope changes from positive to negative or vice versa. Okay, so at the start, it's negative, right? The slope is negative. But then it changes right here at 2, right? So 2 is going to be one of them. And then it goes over here and changes right here. Changes at this value right here, 4.75. And then it changes one more time from negative to positive at 6. So these guys right here are my points of inflection. Justification, because f double prime changes signs. F double prime changes signs. Okay. Concave up, concave down. Concave up, concave down. So concave up, concave down, we said when the slope of the graph is positive, concave up. When the slope of the graph is negative, concave down. Okay. So from 2 to 4.75, or from 6 to 8, that's where it's concave up, because f double prime is positive. And from 0 to 2, or 4.75 to 6, since f double prime is negative. Okay. And then the last one. The last one looks harder than it actually is. Find the derivative of that guy. Okay. Because it says find g of 2, right? So g prime of x equals the derivative, which is 2x, minus f prime of x, right? Now plug in 2. Two times 2 is 4. How do I find f prime of 2? Graph, yeah. Find out where the graph is. Where is the graph? What's the y value when x value is 2? Negative 2. So 4 minus negative 2, positive 6. Okay. All right. Okay, so I'm going to post an assignment. Hasn't been posted yet. It's posted. It's not a big assignment because this is not a big section. There's not a lot of questions, but there are some important questions. So I'm going to post that today. Okay, it won't be due till Thursday, but I'm going to post it today. And that's about it. All right, guys. I will see you tomorrow.